Okay, so the last way that we're going to use this normal curve for Module 5 is if we're looking for a specific point on our curve or a specific value on our curve. So we're actually going to we're going to work backwards. So we're going to go from a probability to a z-score to a value. So that's what you can kind of see here. Here we will work in the reverse direction from a percent probability to a z-score from the table to the x using the formula. So we'll take a look at how we use the table, and then we'll take a look at how we can use Excel for this as well. So here we have a company in California is concerned about the length of time that its employees spend commuting to work. The one-way commute times for its employees are normally distributed with a mean of 32.1, so there's our mean, and a standard deviation of 5.3. What is the commute time that separates the longest 20% of commutes from the rest? So if we think about like looking at this drawing, and we'll take a look at this one first because it deals with the half the curve using the table. So it wants to know about this 20%. Okay, but if you think about when using the curve as a half, the the value that is here, we wouldn't use 20% or 20%, the probability of 20% is not attached to this value. So we need to know the probability that's attached in this sense because we're looking at the table with looking at the curve as a half, is looking at from this to here, which we know from the mean the whole way out is 50%. We know that this is 20%, which means we want to find the z-score that is attached to our 30% or the probability of 30. So to use the table, if I go to my table, what I want to do is I want to look in this table and find what is closest to 30%. And I spotted it kind of quickly. It kind of falls in between here. So we have 0.8 and then we have 0.84 and 0.85. So we'll probably take 0.84 because it's the closest. So, and that's what they did, 0.84 because it is the closest. Okay. So what that means, that probability is now we have a z-score. So if you think about the formula that we had, right, where we have z is equal to the x value minus the mean divided by standard deviation. Well, what we can do is we can reorder that into now solving for the x. Now, if you are good at algebra, you could use that z equals x minus mu over standard deviation, plug in what you know and solve for the x value. Or you can use this formula, which is x, which is the point we want to observe, is equal to the z times the standard deviation plus the mean. Okay, so if we take the 0.84, which is the standard deviation, or sorry, the z-score, and we times it by the standard deviation of 5.3, and we add the mean to it of 32.1, we get a value of 36.6. So 36.6 minutes is the commute time that separates the longest 20% of commutes from the rest. So that's this actual x value here. Now, if we're using the bigger table, kind of just think of the same thing the way we started out was how we solved for this to be 30%. Well, the cumulative table looks at it from this point the whole way to this point. So the probability that's attached to that, if this is 20%, then from here to here is 80%. So when we use our table, or when we go to our table, and we know it's to the right side of the curve, so we don't even have to deal with the negative z-scores. But what we want to find is the probability that is closest to 80%. So as I'm going down the list, I see it's this one here, 0.84. So it's the same standard deviation or same z-score that we had, 0.84. It's the same one that we had. So 0.84, plug into the formula, and we get 36.6. So same thing, but just our starting point of finding the z-score is slightly different. Now, for Excel, there's actually a formula for this. If you go to the statistical, go to the normal distribution area, And now what you're going to do is, instead of doing normal dist, you're going to do normal INV, which is the inverse. And why did it show up way over there? Okay. So the probability is 0.8, right? 80%. The mean, what was the mean? The mean was 32.1 minutes. So 32.1 minutes. And the standard deviation is 5.3. So 5.3. And we hit OK. And we have rounded 36.6 minutes. Would be our answer. 36.6 minutes is the commute time that separates the longest 20% commute. Okay, so there are multiple examples of this, but that's kind of the idea of how we can use it. It's once you understand how these graphs work or how the tables work, you can find the tables once again in your course materials tab, and then also you can use Excel to solve for these. I highly recommend for normal and uniform, go ahead and draw them and find out what you're looking for, and then write in the probabilities that are attached to each. That way you have an idea of how you can solve for what's being asked. All right, guys, keep working along. You have any questions, please feel free to reach out to me.